In this demo, I'll show you around the JackBitmapEditor, explaining the features and describing some of how you can use this to create animations for your programs on the Hack platform. This is an extension to the bitmap editor developed by Golan Parashi, and you might ask why it needed to be updated. The first reason is simply to have more features, such as the ability to make arbitrarily large bitmaps rather than having to piece together multiple when you want a large character or object in the game. But the main reason for the upgrade is for creating animations. See, the way the hack screen works is by storing pixel information in sets of 16 bits in the RAM. Here is why this causes a problem. Let's say you have a drawing function and you have called it with location 5. If you then want to move it just a little to the left and call the function with location 4, suddenly the drawing moves 16 pixels to the left, and there is no in-between. You are confined to multiples of 16 pixel movements in the horizontal direction, but for animation it is much better to have the drawing move 1 or 2 pixels at a time for smoother animation. So that is the problem that this updated version of the bitmap editor is meant to solve. The ability to easily create animation frames that can move by drawing an individual pixel left and right. And that is what most of the features relate to. But even if you do not care about creating animations, you might find the bitmap editor useful due to the features that I'll soon describe. Most of the features are clearly documented in the README file and should be understandable, so I'll focus on the ones that might seem confusing and give insight to how the editor is interpreting the drawing and generating code for it. The editor has the options of fit to drawing, rectangular, and full canvas mode. The mode selected determines the region of the canvas that will have the code generated for it. Full canvas mode works exactly like the previous versions of the bitmap editor. Code is generated for every pixel of the canvas. So as you can see, before I have drawn anything, the code is simply poking a bunch of zeros into the memory, since zeros refer to a blank group of 16 pixels. Now if I make the edges of those 16-bit pixel groups obvious, you can see that these are on the left of every 16 pixel group, which makes sense since each group is being included in the code. Shifting the drawing moves it relative to these edges but has no other effects, while it does in the other two modes. Some people might find this mode to be the most straightforward, though if you want efficient code, you will have to resize the canvas to better fit for the drawing. Another use of this mode is if you have a sprite that is made up of large sections of both black and white, and I'll explain why that matters in a minute. If you are experiencing strange bugs in either of the other modes, let me know and try the full canvas mode in the meanwhile, as there's very little code to go wrong in this mode. Fit to drawing mode is a little more intelligent and only generates the minimum code necessary for your drawing. As you can see, before drawing anything, no code is generated, but as soon as I start drawing, code is generated for the area of the drawing. You can also see that the 16 pixel word edge boundary has lined up with the left edge of the drawing. These lines indicate the number of word columns that are generated in the code, so that the second one will only appear once your drawing is larger than 16 pixels in width. The leftmost of these lines always lines up with the left edge of the drawing before any shifting has been applied. So you can move the drawing relative to these boundaries simply by using the shift buttons, and this will be very useful for animation frames, as we'll soon see. Since this mode is ideal for animations, there's other additional features that correspond with it. You'll notice that there's now an option to choose the number of horizontal shifts that you use between frames in an animation. Let me show you why this is important. I'm going to make a quick drawing to show you what this does. So you'll see that a portion of the drawing is in column 1. Now what happens as I start shifting this over to the left? Just when I cross over the word boundary, column 1 has commands to poke 0 in the locations where the dark pixels had just been. This is a time when zeros are actually included in the generated code, and they are necessary to erase the black pixels that had previously been in those words. Now, if my animation required that I move over twice per frame, those zeros would disappear and I would be left with columns of black pixels that had not been properly erased when playing the animation. So in this case, I can change this value to 2, and the editor will remember where the drawing was for 2 frames and supply the necessary erasing. A quick tip for animators. For animations, you will need frames in which the drawing completely crosses a 16-pixel word group. So if you want a 16-frame animation, use 1 pixel shift per animation frame. If you want 8 frames, as I used in my game, use 2 pixel shifts per animation, and so forth. One note on both fit to drawing and rectangular mode is that the area of the drawing is determined by the pixel colors. Normally, black pixels are considered the part of the canvas that is the drawing, but in inverted mode, white pixels are instead considered the drawing, and sets of 16 black pixels are used for erasing the drawing when it crosses a word boundary. Rectangular mode is like a cross between the others. It is mostly like fit to drawing in that it adapts to the size of the drawing, but is like full canvas in that when it finds the minimum enclosing rectangle around the drawing, it includes every group of pixels within it. This could be useful if you want to make large drawings with blank spaces in them, or want to use something similar to full canvas but with slightly more efficient code. The purpose of shifting is entirely to move the drawing relative to the word boundaries, and clicking clear shifting leaves the position of the drawing unchanged, but undoes the effect of shifting, thus realigning the leftmost word edge with the leftmost edge of the drawing. Switching between top left and bottom left base address is never necessary, but it could be nice for some applications. Essentially, the graphics function that is generated defaults to using the inputted argument called location to refer to the screen location of the top left corner of the drawing. If it would be easier for your application to keep track of the location of the bottom left corner instead, you may select this, and the function will shift all the poke addresses to fit your preference. The option to change name with horizontal shift is something that I added to the editor for my own convenience, but you might find it nice as well. Simply, it will change the subroutine name with an appended number when you shift the drawing, so that you do not have to manually do this for animation frames. Now that you know these features, making animation should not be too hard. Simply draw a sprite and move it how you like with the shift buttons, copying the function generated to your program for each frame. For the animations in the Dino Adventure game I made, I used 8 frames per change in screen location, so I shifted twice per frame. A best practice I found for leftward animations was to shift twice before copying the first frame function, then repeatedly shifting twice and copying until I had copied over the draw 8 function. Then, in the update loop, I would simply call sequential functions, and on the 8th I would decrease the object's location by 1. If you are experiencing trouble with the animations not erasing properly, a troubleshooting method is to see how the frames progress on the JackBitmapEditor and see when the drawing crosses a word edge, which is the time that residue is possible. Then see if you might need to erase anything that the bitmap editor missed, and if it seems like a bug, please report it. I hope you enjoyed this demo and would love to see what you create with the bitmap editor. Post links to your code, game, or animation in the comment section, as well as sharing tips with other coders. Thanks for watching.